everyone, we're going to find the length of the curve for y equals e to the power of x plus e to the power of negative x, all divided by 2 over the interval -1 to 1. So basically we're going to use this formula, and we have y, so we want to differentiate our y with respect to x. And that's going to give us e to the power of x minus e to the power of negative x divided by 2. And then you just use this formula here to find the length of the arc. So our length is going to be from the integral from -1 to 1. Then you write the square root of 1 plus, and then we're going to take our derivative of y with respect to x, which is e to the power of x minus e to the power of negative x divided by 2. Then you square it, and it's going to be dx. All right, we're going to expand this, and just please note that we're using a minus b squared. That's a squared minus 2ab plus b squared. So the middle term is going to be negative e. Let's see. It's going to end up being negative 2e to the power of x times e to the power of negative x. So that's negative 2 times e to the power of x minus x. And e to the 0 just equals 1. So we'll just get negative 2 there. Just want to make sure we understand that. So we're going to go have our integral from -1 to 1, square root, and we're going to have 1 plus e to the power of 2x, and now we're going to have minus 2, which is what we already got here, and then plus e to the power of negative 2x, all divided by 2 squared. Now what I can do is go ahead and square this 2. Now I square the 2, I'm going to get 4, and I'm going to get the common denominator. So for example, I'm going to have this and make this all under 4. And if I do that, I have to multiply this by 4. And then I'm going to have plus e to the power of 2x minus 2 plus e to the power of negative 2x. All right, and this shouldn't be squared here. All right, now I can pull out the square root of 4, which is 1/2. I can write this as 1/2 times the integral from -1 to 1. And then we have 4 minus 2 is 2. So that's going to give me e to the power of 2x plus 2 minus, or plus again, plus e to the power of negative 2x dx. So I'm going to write it again. I know I squeezed it in there. Let me write it again. We're going to have 1/2 times the integral from -1 to 1 of square root of e to the power of 2x plus 2 plus e to the power of negative 2x dx. All right. Now this is a perfect square trinomial, so I can write this as 1/2 times the integral of -1 to 1 times the square root, and I can write this as e to the power of x plus e to the power of negative x squared dx. All right. Now that I have that, since it's a square root, I can use symmetry for this and change my upper and lower limit from 0 to 1 as long as I multiply my 1/2 times 2. So we're just getting half the length, and then we're going to multiply it by 2. And then when you take the square of a square root, that gets rid of that, and we're just left with e to the power of x plus e to the power of negative x dx. All right, this just equals 1. So now let's integrate this. So this is going to be e to the power of x minus e to the power of negative x, and we're evaluating this from 0 to 1. This is going to equal e to the power of 1 minus e to the power of negative 1. Then you subtract e to the power of 0 minus e to the power of 0. All right. So this right here is just going to be 0, because this is 1 minus 1, basically. That goes away. So our final answer is just going to be e minus 1 divided by e, if you get rid of that negative exponent. And that's the length of your curve. Thank you. Have a nice day. Bye-bye.